Bright Tuty. Every student matters.
Hello students, let us continue the chapter Algebraic Expressions and Identities. So what we are going to do, we have already discussed all the concepts. So basically in the last one we were discussing the identities. So we discussed 4 standard identities. Now using those identities we are going to practice a lot of questions. So let's start the practice. As you can see, here is one question given. We have to use a suitable identity to get each of the following product. So we have to use a suitable identity for all. So let us start with the first part. In the first part of the question, we are given x plus 3 multiplied with x plus 3. So x plus 3 multiplied with x plus 3 can be written as x plus 3 whole square. Okay. Now as we see, it is a plus b whole square. So we will use the identity a plus b whole square, which is equal to a square plus 2ab plus b square. Okay, so comparing this with this, we get a as equal to x and we get b as equal to 3. Just see, this is a, right? So it is equal to x and b here is 3. So we will put instead of a as x and instead of b as 3. So let us put it here. So instead of a, put x square of x plus 2 into x into b is 3 plus square of 3. So we get x square plus 6x plus 9. So this is the answer. Right, so we don't have to multiply each term of the one binomial with the another binomials each term. We can just use the identity to solve it, right? So now we will start the second one. Okay, so in the second one we are given 2y plus 5 multiplied with 2y plus 5. It is equal to 2y plus 5 whole square. The same number multiplied with its square, we get the square of that number. So 2y plus 5 whole square, if we compare it, this is can be equated to or can be compared with a plus b whole square. We know a plus b whole square is a square plus 2ab plus b square. Comparing this to a plus b whole square, we have a as equal to 2y and we have b as equal to 5. So let us put that here. Instead of a square, we will put 2y whole square plus 2 into a is 2y, b is 5 plus b square, that is 5 whole square. So we get 4y square plus 2 2s are 4, 4 5s are 20, 20y plus 25. So this would be the answer. This is the square, or when we multiply 2y plus 5 with the 2y plus 5, we get this. Is it clear? Now we're going to try the next part of this question. It is part number 3. So in the third part of the question, we are given 2a minus 7 multiplied with 2a minus 7. It is equal to 2a minus 7 whole square. Right? So if we compare it to a minus b whole square, we know a square minus 2ab plus b square. This is the second standard identity. If you remember, we did it in the last lecture. So this identity we are going to use to solve this question. Okay, so what is the value of ABC? A here is 2a, right? Or we can just write it here instead of the one a, we have 2a actually. So 2a square minus 2 into 2a into b is 7 here plus 7 whole square. So we get a square will be a square, 2 whole square will be 4 minus 2 2s are 4, 4 7s are 28, 28a plus 7 square is 49. So this is the answer. Right? So using the suitable identity, after having a look over the question, you have to use. Okay, let's move ahead to the next part. In the fourth part of the question, students, we are given 3a minus 1 upon 2 multiplied with 3a minus 1 upon 2. right? Now it is a minus b into a minus b. It becomes, so from this we get 3a minus 1 upon 2 whole square, and it is equal to a minus b whole square. We know a minus b whole square is a square minus 2ab plus b square. Let us use this here. 3a whole square minus 2 into 3a into 1 upon 2 plus 1 upon 2 whole square. So we see 3a whole square is 9a square minus 2 and 2 gets cancelled. We get 3a plus 1 upon 4. So this would be the answer of it. Are you getting what we are doing? Using the suitable identities, we are finding out the product. Okay. Now, in the fifth part, we are given 1.1 m minus 0.4 and 1.1 m plus 0.4. Okay. Now, it is just to see a minus b into a plus b. Just to see the value here and here, it is same, so we call it as a, and the second value is also same. The only change is the sign in between them. So it is a minus b and a plus b. We know that this is equal to a square minus b square. This is the third standard identity that we learnt in the last lecture. So we are going to just solve it. It will be equal to a square minus b square. So after comparing, we know that a is equal to 1.1 m and b is equal to 0.4. So 1.1 m whole square minus 0.4 whole square. So what will we get? 1.1. It will be 1.21 square of it, and m square minus 0.4 square is 0.16. So this is the answer. So directly just to see, just by doing the square of two numbers, we got our answer. So we are using here the identity a minus b into a plus b. It is equal to a square minus b square. Now let's move to the sixth part of the question. In the sixth part, we have a square plus b square into minus a square plus b square. Okay, so just to see what is the change here. If I write it as b square plus a square and b square minus a square, are these two same? Yes, they are same. Okay, now what we can apply here, it is a plus b and a minus b. So it will be equal to a square minus b square, like this. This is what we are going to use. That means we will subtract the square of these two. So let us just put the value. So instead of a, we have b square. So b square whole square minus a square whole square. We get b to the power 4 minus a to the power 4. See, it is of the form, I can, because already a and b are used, so I am using x and y. It is x plus y and x minus y, which is equal to x square minus y square. So this is the result that we have used to solve it. Okay, we have learnt in the variable form of a plus b and a minus b. We can have any variable. Already a and b are there in the question, so I am using x and y. Okay, to make a difference only. So this would be the answer. Let's go to the next part of the question. Now the seventh part. In the seventh part of the question, we are given 6x minus 7 and 6x plus 7. So what is given to us? We are given a minus b and a plus b. Right? Comparing this, we have a as 6x and b as 7. Okay, and it is equal to a square minus b square. So what will be the answer of this identity? It will be equal to 6x whole square minus 7 square. And you know 6x whole square is 36x square, right? Minus 7 square is 49. So this is what your answer for this question. Okay, now let us try the next part, eighth part of this. Okay, in the eighth part of the question, we are given minus a plus c minus a plus c. So what we observe here is, it is minus a plus c whole square, correct? Or we can also write it as c minus a whole square. This is C minus A only. C is of plus, A is of minus. So we can use A minus B whole square here. We know A minus B whole square is A square minus 2AB plus B square. So we will use this. Instead of A, we will put C. C square minus 2 into C into A plus B square is A square. So C square minus 2AC plus A square. This would be the answer of this question. Okay. Let's move to the next part, that is the ninth part of this question. So in the ninth part, what we are given? X upon 2 plus 3y upon 4. X upon 2 plus 3y upon 4. This can be written as x upon 2 plus 3y upon 4 whole square. So it is what? A plus B whole square, right? And it is equal to A square plus 2AB plus B square. You need to remember the result. You have to learn it. Now, what is A here? A is x upon 2. And what is B? B is 3y upon 4. Let us put this in the formula. So, what we will get? We will get x upon 2 whole square plus 2 into A, that is x upon 2, B, that is 3y upon 4 plus 3y upon 4 whole square. Right? So what we are going to get after solving this? Let us write it here. So we will get x square upon 4 plus 2 and 2 got cancelled, 3xy upon 4. 3xy upon 4 plus 3 3s are 9, y square upon 4 4s are 16. So this is the answer of question number 9. Clear? So I hope you're understanding how identities, how these standard identities are helping us. Okay. Now let us discuss the next part, that is the 10th part of the question. In the 10th part, we are given 7a minus 9b. 7a minus 9b. So it is equal to 7a minus 9b whole square. Now I think you all can imagine or just understand which identity is to be used. Just think about it. We are going to use, yes, we are going to use a minus b whole square, that is a square minus 2ab plus b square. So comparing it, a is equal to 7a and b is equal to 9b. Let us put it here. 7a whole square minus 2 into 7a into 9b plus 9b whole square. So we get 7 sevens are 49, a square minus, just see, 2 sevens are 14. 14 into 9, just multiply it. 9 fours are 36. 3 is the carry. 9 ones are 9 and 3. It is 12. Right? Just do it again. 9 fours are 36. 3 I have taken the carry. 9 ones are 9 and 3 is 12. So we get 126 AB plus square of 9 is 81 B square. So this is the answer. Right, so we have discussed 10 questions in which we had to, identify or think which identity is to be used, and using that identity we have solved the products. Okay, let's move to the next question now. Here is the next question. You have to use this identity. It is already given x plus a into x plus b equals x square plus a plus bx plus ab. Right? So in the first part of the question, so what I'll do, I'll just keep the identity ready with me, that x plus a into x plus b, this is equal to x square plus a plus bx plus AB. And I would suggest you to write this identity in all the parts again and again, so that it is learnt by just writing. Okay, you don't have to make extra efforts on it. Now, just to see, what is this? We have x plus 3 and x plus 7. So when you compare it, what is x? X is given as x only, so that is fine. What is a equal to? A is 3 and b is equal to 7. So here we will put x square, that means x square plus a is 3, b is 7, x plus 3 into 7, that is a into b. So we get x square plus 7 and 3 is 10, 10x plus 7 3s are 21. So this is what we are getting. Right? Is it clear? So now what we have done, the identity which is given in the question, using that identity we have solved the product. Okay, let's move to the next part. Okay, so see, there are 7 parts in the question, so it is going to give you a very good practice of this identity, and of the other 3 identity we have done a lot of practice in question number 1. So now let us see the second part. We have 4x plus 5 multiplied with 4x plus 9. So using this identity now, okay, x square, what is x square for us? 4x. So 4x whole square plus a plus b we have to add. A is 5 here, b is 1 here. So 5 plus 1 into x plus ab we have. So a is what here? 5. B is what here? 1. So just see, 4 4s are 16x square plus 5 and 1 6x plus 5. So this would be the answer. So directly using the identity we can easily solve it, right? Okay, so now we are going to start the next part. In the next part, what we are given, the third part of the question, 4x minus 5, 4x minus 1. If you compare with this, instead of x, what we have? Instead of x we have 4x. So 4x whole square plus, instead of a, what do we have? 5. So instead of a, I'll write 5. Instead of b, what do we have? Okay, one more thing. Just see, it is minus 1 minus 1. So before solving it, it is for your clarity, I would rather like to write it as, just see in the third part, this I will write 4x plus minus 5. Right? And the second one I will write as 4x plus minus 1. Right? What does that mean? That means you always have to take the sign along with a and b, because in between the identity that we are using, x and a and x and b, the sign in between those is of plus. So we have also made it as a plus sign, but we have to take minus 5 and minus 1, because in the question it is given minus. Plus minus is minus. Okay, so now instead of x, what do we have? 4x. So instead of x square, we will write 4x square plus, what is a now? Comparing it to a is minus 5, and what is b? Minus 1 into x plus a into b. So 4x square is 16x square. Then minus 1 minus 5 is minus 6x. And minus 5 into minus 1, that is 5. 5 multiplied 1 is 5. And minus in multiplication gets plus. So plus 5. So this would be the answer of your third part. I hope it is quite clear. Now let's go to the fourth part of it. Okay, in the fourth part of the question, we are given 4x plus 5 and 4x minus 5. Now in one we have plus sign, in the second one also we have to make it plus. So 4x plus minus 1, like this we can write. So comparing it with x plus a and x minus a, which is equal to x square plus a plus bx plus b, not b square, it is ab. Okay, comparing it with this, what do we have? We see that x is 4x, so instead of x square we will have 4x square plus, what is a here? A is 5. What is b here? Minus 1. And then x plus 5 into minus 1. So we will have 16x square plus 4x minus 5. Right? So we have to make the negative sign, we have to write the negative numbers inside the bracket and put a plus sign outside it, so that we are easily differentiating between a and b. So as in the identity it is plus, we are using plus so that we can compare easily. Okay, otherwise many students forget to take the sign along with the number. So it is better that you write it in this form and then apply the identity. There will be no chances of mistakes then. Okay, now fifth part we are going to do. In the fifth part of the question, we have 2x plus 5y and 2x plus 3y. So if I compare with x plus a and x plus b, what is x here? 2x. And what is a? 5y. What is b? 3y. So this is equal to x square plus a plus bx plus ab. So instead of x, we will write 2x whole square. Okay. Plus a. A is what, as you can see in the question? A is 5y. And what is b? B is 3y. into x plus 5y into 3y, that is a into b. Now square of 2x whole will be 4x square plus 5y and 3y is 8y. 8y into x is 8yx plus 5 3s are 15. Y into y forms y square. Clear? So I hope this is understood. Now let us try the next part, that is the sixth part of it. Okay. So in the sixth part, what we are given with, in the sixth part of the question, this one, that means we are given 2a square plus 9 into 2a square plus 5. Okay, so instead of x, what do we have? Just see x plus a and x plus b, which is equal to x square plus a plus b into x plus b square. So what is x here? 2a whole square. This is x. What is a here? Just see, it is 9. What is b here? Just to see, it is 5. Okay, now because this a and this a here are different, okay, because x is given in terms of a only. Otherwise you can use any other variable here. I can use here y plus a and y plus b, the identity will remain the same. So instead of x, what we will put? 2a square whole square, okay, plus a is 9, b is 5 into x plus it is ab, not b square, it is ab. So a is 9, b is 5. So 4a to the power 4 plus 9 plus 5 is 14, it will be 14x plus 9 5s are 45. Okay, so this is clear. Now let's try the next part, that is seventh part. So in this we are given xyz minus 4, xyz minus 2. So you see the first term is same and the a value of a and b are different. So first of all, let us convert it in the form of identity. So we will write it as xyz plus minus 4, and the second one is xyz plus minus of 2, like this. So here instead of x we have xyz, instead of a we have minus 4, instead of b we have minus 2. So let's apply the identity. First of all, it is x square, that means the first term. So xyz whole square plus a plus b into x. What is a? Minus 4. What is b? Minus 2 into x plus a into b. What is a? Minus 4. What is b? Minus 2. So we get x square, y square, z square. Okay, minus 4 and minus 2 is minus 6. Minus 6 multiplied with x, minus 6x. Then we have 4 into 2 is 8, and minus minus in multiplication, it will be plus. So plus 8 we will get. Clear? So this is the seventh part answer. So I hope use of this identity is clear, how to apply this to the questions or the polynomials that are given to us. Okay, let's move ahead now. In this question, they're asking find the following squares by using the identities. Now we have to identify which identities to be used. It is not mentioned in the question. So that's why I always say you have to learn the identities. In the first part, we are given b minus 7 whole square. Okay, so we know a minus b whole square. Okay, or we can say just in terms of x and y, because b is already used in this, what I can use? X and y. So x minus y whole square is x square minus 2xy plus y square. So the same identity that we had in form of a and b, I have written that using the variables x and y. Variables can be any. Okay, so here if we compare what is x, x is b and y is 7. Let us put in this formula. So x square, it will be square of b minus 2 into x is b, y is 7 plus y square. So y is 7 square. B square minus 2 sevens are 14b plus 49. So this is going to be your answer. Okay, now let us try the second part of it. So in the second part of it, what we have to do, just to see what is the polynomial that is given to us. The polynomial given to us is xy plus 3z whole square. So can you think of the identity that we have to use? Think about it. We have already learnt it. So it is a plus b whole square, right? So we will use a plus b whole square, that is equal to a square plus 2ab plus b square. Now after comparing these, we know that a is equal to xy and b is equal to 3z. Okay, let us put the value of a and b in the identity. Is in place of a, we will write xy plus 2 into a is xy, b is 3z plus b square is 3z whole square. So we get x square y square. Okay, let us multiply this. It is 2 and it is 3. 2 into 3 gives us 6. X, y, z. X, y, z. Plus 3 square is 9. Square of z is z square. So this would be the answer of the second part. Right? So it is on you to identify which is the suitable identity that we have to use, and then you should remember the identity also to apply it quickly to the question. Okay, now the third part we are going to solve. So what is given in the third part? Can you think of the identity that we have to use in the third part? Yes, the third part is 6x square minus 5y whole square. So we see this is of the form a minus b whole square. Okay, it is equal to a square minus 2ab plus b square. So now by comparing, we know that a is 6x square and b is 5y. Okay, so putting the values in the formula, 6x square whole square minus 2 into a is what? 6x square. B is what? 5y plus b square, that is 5y whole square. So 6 6 is 36, x square whole square is x to the power 4 minus 2 6 is 12, 12 5s are, you need to think, right? Just to see, 60 it will be, 2 6 is 12, 12 5s are 60 and x square y we have, plus 5 5s are 25, y square is square of y. So this will be the answer of third part. I hope the question is quite clear. Let us think about the next part, that is the fourth part of this question. So can you think of the identity that we have to use? Yes, we have to use a plus b whole square. So the question is 2 upon 3m plus 3 upon 2n whole square. It is of the form a plus b whole square and the identity is a square plus 2ab plus b square. Whenever in exam you attempt the question or apply the identity, you always have to mention the identity, right? There is always marks given for the formula, for the identities that you use, right? Don't miss them in solution. So comparing it, a is equal to 2 upon 3m and what is b equal to 3 upon 2n. Okay, now what we are going to do, we will put these values of a and b. A is 2 upon 3m, so 2 upon 3m whole square plus 2 into what is a? 2 upon 3m. What is b? 3 upon 2n plus b is 3 upon 2n whole square. So we will get 2 2s are 4, 3 3s are 9, m to the power 2. Now just to see, 2 and 2 got cancelled, 3 and 3 got cancelled. We are left with 2mn. So 2mn plus square of 3 is 9, n square upon square of 2 is 4. So this will be the answer of this part. Quite easy to do. Okay, now we will try the fifth part. What is given in the fifth part? Can you think of the identity? In the fifth part, we are given 0.4p minus 0.5q whole square. So it is of the form a minus b whole square, which is a square minus 2ab plus b square. Now I hope doing the chapter only, doing these questions only, you might learn the identities by the time we complete the exercise, because we are writing them in each and every question. So when you attempt the exercise, you also write the identities in each and every part of the question. That will make you learn the question. Also you will have a habit of writing the equation, so that your exams are done well and no marks are deducted for these silly mistakes. Okay. So after comparing, we know that a is equal to 0.4p and b is equal to 0.5q. Okay, let us put it here in place of a and b. So a is 0.4p whole square minus 2 into 0.4 into 0.4p into 0.5q, that is the value of b, plus 0.5q whole square. So 0.4 whole square if we are doing, we will get 0.16 p square. Then minus 2 into 0.4 is 0.8. 0.8 into 0.5. Just see. If you have some confusion in multiplying the decimals, like you are not doing it orally, so what you can do, replace the decimal or with tens or hundreds, whatever the number of digits are there after the decimal. So just see, we will write it as 2 into 0 4 upon, or just write 4, okay, to avoid the confusion. So we will write 2 multiplied with 4 upon 10 after removing the decimal, p into 5 upon 10 q plus 0.5 whole square will be 0.25 q square. So just to see here, what we get, 0.6 p square minus, here this will remain same, 0.25 q square. So just see, 2 4s are 8, 8 5s are 40, so we actually get 40 upon 100. Right, 10 into 10 is 100. So cancelling 1 0, we are just left with 0.4 p multiplied with q. So this is going to be your answer. So whenever it comes to decimal, and sometimes it is difficult for you to just answer it orally or multiply it, you do a mistake in decimals. So just you can remove the decimal, multiply the things, and then can put the decimal again. Okay. Now the last part, that is the sixth part. Okay, in the sixth part of the question, we have 2xy plus 5y whole square. So what is the identity that is to be used? I think all of you now can imagine and tell definitely the correct identity to be used. It is a plus b whole square. So it is a square plus 2ab plus b square. The value of a is 2xy, the value of b is 5y. Let's put in the formula. Instead of a, we have 2xy whole square plus 2 into a is 2xy, b is 5y, plus the value of b is 5y, its whole square. So square of 2 is 4. Very good. Square of x is x square into y square plus 2 2s are 4, 4 5s are 20. 20x y into y will form y square plus 5 square is 25 y square. So this would be the answer of this question. Right. So we have discussed all the parts, and looking on the question, now we are able to identify which identity we have to use. Right. So let's go ahead now. Here is another question and you need to simplify it. Okay. So how do we simplify it? The first part is given as a square minus b square its whole square. Right, so we can compare it with x minus y whole square, and it is equal to x square minus 2xy plus y square. I am using the identity of a minus b whole square only, but why I am using the variable x and y? To just make a difference between the a and b used in the question, and that I am using. Okay, so now what is our x after comparing a square? So a square whole square minus 2 into what is a square. After comparing, what is y? What is x? A square. What is y? B square plus y is b square. So b square whole square. We get a to the power 4 minus 2a square b square plus b to the power 4. This would be the answer. Is that clear? Okay. So now we are going to try the next part. In the next part, what are we given with? In the next part, that means the second part I am talking of, 2x plus 5 whole square minus 2x minus 5 whole square. So how is it given? It is not of the form a square minus b square, because see, a square minus b square, can we use that? It is a and it is b. Yes, we can use that. It is equal to a plus b into a minus b. So this is our a, this is our b. So it is a square minus b square, which is equal to a plus b into a minus b. So let's apply this. Just see, a is what? 2x plus 5 a plus b is what? 2x minus 5. So a plus b is done. Now a minus b. What is a? 2x plus 5 minus b, 2x minus 5. So like this we will use here, because here is a negative sign. We need to see that also. Take this into consideration. Most of the students commit a mistake here only. They don't use this bracket and just write 2x minus 5, and that makes the whole question wrong. Now 2x and 2x makes 4x, 5 and 5 will get cancelled. Multiplied with, what are we left inside here? 2x plus 5, because there is a minus sign, the signs of the expressions, or I say the terms inside, will change. So we'll write minus 2x, and minus will be plus 5. So 2x and 2x will get cancelled. 5 and 5 is 10. We get 4x multiplied with 10, and that gives us 40x. Is that clear? Otherwise, you can use a plus b whole square in this, a minus b whole square in this, and then can subtract from this the square of this, right? But that would be a lengthy method to do. You will be using two identities. Instead of that, you just consider this complete as a, this complete as b. So it is a square minus b square, which is equal to a plus b into a minus b, right? Okay, now we're going to discuss the next question. In the next question, that is the third part of it, we are given with 7m minus 8n whole square plus 7m minus 8n whole square. Okay, we have plus in the second part. We have plus here. So how to use this? How to solve this? We see this is of the form a minus b whole square plus this is of the form a plus b whole square. Correct? We know a minus b whole square is a square minus 2ab plus b square. We know a plus b whole square is a square plus 2ab plus b square. So can we simplify it so that at the end whatever answer we are getting, we don't have to cancel, just try to cancel the terms inside. That means if we have something in this form, 2ab and 2ab can get cancelled. A square plus a square is 2a square plus b square plus b square is 2b square. So whenever we have something like this, we can just solve 2a square plus 2b square, and that will give us our answer. So we see here a is what? A is 7m in both of them, and B is 8n in both of them. So instead of A, we will put 7m whole square plus instead of B, what we will put? 8n whole square. So 2 into 49m square plus 2 into 64n square. Yes, we can multiply it. 2 9s are 18, 1 is the carry, 2 4s are 8 and 1 9. M square plus 2 4s are 8, 2 6 are 12. N square. This would be your answer, right? So see, we don't have to solve this and this completely. We just have to solve this because this is actually equal to this only. From this we got this, right? So these are some of the tricks that you can apply and make your question solution easier and less time consuming. So let us now try fourth part. We are given 4m plus 5n whole square plus 5m plus 4n whole square. So what is the identity that we are going to use? We are going to use a plus b whole square in both of them. In the first one, what is a? 4m. 4m whole square plus 2 into a, that is 4m, plus b is 5n, plus b square, that is 5n whole square, plus in this we have a as 5m square plus 2 into a, which is 5m, b which is 4n, plus square of b, that is 4n whole square. So what we get? We get 16m square plus 2 4s are 8. We have 2 into 4m into 5n. So just see, 2 into 4 is 8. 8 5s are 40. 40mn plus 5n square, that is 25n square, plus 5m square is 25m square, plus 2 into 5 is 10, 10 into 4 is 40, 40mn plus 16n square. let us combine the same terms. 16m square plus 25m square. Okay, so we are going to combine the same terms. What is combining? 16m and 25m square. 16 and 25. Add them. 5 and 6, 11. 2 and 1, 3 and 1, 4. We get 41. So 41m square plus 40mn plus 40mn will give us 80mn. And then 25n square plus 16n square. So 25 and 16 we've already added, that is 41n square. This is going to be the answer of fourth part. Is that clear? In both of them we have to use the identity a plus b whole square. So whenever you start using the identity, just write before that a plus b whole square is a square plus 2ab plus b square. It is for getting full marks in the question and avoid getting less marks, so that because of the silly mistakes your marks are not cut. So always try to write the identity whenever you start doing any questions, right? First identify which identity is to be used and then apply the identity. Right? Okay. Now out of these questions we have done fourth. Let us try the fifth part now. Okay. What is given in the fifth part? In the fifth part we are given 2.5p minus 1.5 q whole square minus 1.5p minus 2.5 q whole square. So we see it is a minus b whole square, it is also a minus b whole square, and in between we have a negative sign. So a minus b whole square is equal to a square minus 2ab plus b square. So first of all we will do what? We will solve them separately. Let us first solve 2.5p minus 1.5q whole square. So putting the value in the formula, we will get 2.5p, its whole square, minus 2 into 2.5p into 1.5q plus b square, b is here 1.5q. Okay, 2.5 whole square is 6.25 p square minus, just see, 2.5 into 2 is 5 and 15, that is 1.5 into 5 is 7.5. 7.5 pq plus 1.5 whole square is 2.25 q square. Clear? This is there that we are getting. Now we will solve the second one. What is given in the second? We are given with 1.5p minus 2.5q its whole square. So what we will get, just see here. So 1.5p, so 1.5p whole square minus 2 into 1.5p into 2.5q plus 2.5q whole square. So what are we going to get? Just see, 1.5 whole square is 2.25 p square minus these three terms are same that we multiplied here. So it is going to come as 7.5 pq, right? And then we have plus 6.25 q square. So we got the answers of both. Now we have got the answer for this and this. Now we have to subtract, right? So how to subtract now? What we will do, I'll just write it on the top now. So I'm erasing it, okay, for your, so that we have a space to write down. Okay, just see now what we will do. The first one, which is 6.25 minus 6.25 p square minus 7.5 pq, then plus 2.25 q square. From this we have to subtract 2.25 p square minus 7.5 q p, then we have plus 6.25 q square. So when we solve it, because outside there is a negative sign, we'll change the signs inside. So after this, what are we going to get here? We'll get 6.25 p square minus 7.5 pq plus 2.25 q square minus 2.25 p square. Are you getting here? Then we have minus minus plus 7.5 PQ, and minus plus is minus 6.25 Q square. Did you get it? Now what we are going to do, we are going to combine the terms having p square together, terms having q square together, and terms having pq together. So one thing that we can notice here is this term and this term will get cancelled because they have different signs. Okay, now the rest of the question can be done. So let us just do it here itself. Now what will be the next step? Just to see. So let us combine the terms having p square, so 6.25 p square, and the another term having p square is minus 2.25 p square. Then we have 2.25 q square, and we have minus 6.25 q square, right? So we got this. Now what we are going to do, so we are left with these four terms now. So we will write, just see, 6.25 minus 2.25 gives us 4p square, and 2.25 minus 6.25 gives us minus 4q square. Is that clear? So this is how we are going to solve this question. Now we are left with two more parts, 6th and 7th. Let us do them. In the sixth part, we are given AB plus BC whole square minus 2AB square C. So let us first solve this. What is this? A plus B whole square. So A square plus 2 into AB into BC, right? 2AB plus B square, that is BC square, minus 2AB square C, that I have copied as it is. Now A square B square plus 2a, b into b will form b square. Then we have c, just see, we have c, 2b into b is b square, plus b square c square minus 2ab square c. This term and this terms are like terms with opposite signs, they'll get cancelled. So we have a square b square plus b square c square. So these are the two terms that we are left with. Is it clear? So now we are done with all 6 parts, and the last part, 7th, is left. So let us discuss the 7th part also. So students, what we are given in the 7th part, we are given m square minus n square m whole square plus 2m cube n square. So here, as you see, it is a minus b form. So we'll apply the identity of a minus b whole square. What is a minus b whole square? A minus b whole square is a square minus 2ab plus b square. So put the value. A square is m square whole square minus 2 into m square into n square m, that is 2ab, plus b square is n square m whole square, plus then one extra term that we are given is 2m cube n square. Now we get m to the power 4 minus 2 m square into m will be m cube into n, plus n to the power 4 and square of m will be m square, plus 2m cube n. Just to see, we are going to do, so here we are given this. Okay, so here we have 2m cube n square, and here also just see, this is n square, not only n. So these two terms are exactly same, getting cancelled. We are left with the answer as m to the power 4 plus n to the power 4 m square.